Hello students. So today we will start the second chapter, which is acid, bases and salt. So this is the second chapter in your book, and in this chapter we are going to learn mainly about acid, what are acids, what are their properties, what are their characters, how they react with different substances. When we talk about their properties and their characters, we will mainly discuss how they react with different substances. For example, how acid reacts with metal, okay, how acid reacts with metal oxides, okay, then how acid reacts with metal carbonates, okay, then how metal reacts with metal bicarbonates. Okay, then we will discuss how acid reacts with bases and so on. After that, we will discuss what is the definition of base, what is base, what is their definition, what are the characteristics, what are the properties, and then how bases react with different substances, how bases react with metal, how bases react with metal oxides and all, and how metal reacts with non-metal oxides and all. Okay. So after all this discussion, we will discuss about pH, which is a way of expressing how much strong or weak a particular acid or base is. Then we will learn the significant uses or importance of pH in our daily life. So this is our main area where we have to focus. So let's come to the point. So first of all, we have to learn what is the definition of acid and what is actually acid, what does acid actually means. Okay, so the term acid and bases, I believe all of you have came across acid and bases from class 6 or 7 onwards. So where you have been given the knowledge of acid and bases, what is an acid or what is a base. The knowledge is already given to you from very early stages, from class 6 or 7 onwards. So what is acid actually? What are acid? What are acids? So when we talk about acid, the first thing that comes to our mind is acids are those substances, those things which taste sour. Correct? This is the first thing that comes to our mind. Acids are those which taste sour in taste. Okay? And then the word acid came from a Latin word acidus, which literally means something which tastes sour. So, but the question is this only the single property which defines the acidic nature? Can we identify all substances present in the earth by tasting it? No, we cannot do it. Yes, some things, there are some substances which we can taste, which we can feel, and then we can identify whether they are tasting sour, they are tasting bitter, and based on the taste we can identify the substance. But this is not the case for all the substances. It is not possible, it is not like safe to taste each and every substance. But yes, it is for very general understanding that acids normally taste sour. Okay, this is the first thing. Then acids like acetic acid, acetic acid, which we also call vinegar. Okay, then lactic acid, which is present in milk. Then citric acid, which is present in lemon, etc. So these acids, they taste sour, there is no doubt. But what about other acids like HCl, like HNO3, like H2SO4? Okay, these are also acids. We can taste them. We can tell their taste. But what about this kind of acids? It is not safe. It is not totally safe to taste this kind of acids because they are mineral acids and they are very strong. Okay, so on what basis, on what criteria we are calling them as acid? So the sourness of a substance cannot be the sole criteria to determine whether a substance is acid or base. So we will talk about how we can actually classify or identify whether a substance is acid or base. Okay, so since sourness is not the sole criteria to determine whether a substance is acid or base, so what alternate we can think of? Okay, just try to write down the formula of the acids. CH3COOH is the formula for acetic acid. Then HCl is the formula for hydrochloric acid. Then we have HNO3 for nitric acid. Then we have H2SO4 for sulfuric acid, and so on. Now if you observe closely, then you will see that in each of the formula, be it acetic acid, be it HCl, be it HNO3, be it H2SO4, in all these cases we have one thing in common, that is H. We can see H in all of them. Okay, so now I think you have the knowledge that acids are those substances which does not only taste sour but which also contain at least one hydrogen atom. They must contain at least one hydrogen atom, but that is not the total definition. We are going to the definition one by one, but this is not the total or complete definition. Yes, acids may contain hydrogen, more than one, but on what basis? What kind of atom they are? What kind of hydrogen atoms are they in order to be acid or base? Sorry, not base, only acid. We are talking only about acid, and about base we will come to it in later videos. Okay, so now we have two conditions, that is acids are sour and acids have to contain hydrogen atom. Okay, hydrogen atom. So we have two conditions to fulfill: sourness and have to contain hydrogen atom. Now let me give you two examples. Example number 1, I have CH4 and I have the same compound here, which is CH3COOH, correct? So we have two known compounds with us. One is CH4, which is again a very common compound. This is called methane, and then we have acetic acid. The name suggests that the second one is definitely acid, whereas this one CH4 is not an acid. Now if you observe this CH4, it also has hydrogen atoms, 4 hydrogen atoms, but still this is not considered as an acid, whereas this also has 4 hydrogen atoms, but this is considered as an acid. Why this happens? CH3 COOH. This is acetic acid, this is acetic acid, this is methane. Both this compound contain hydrogen atom, whereas this is not considered as an acid and this is considered as an acid. Not only considered, but in fact this is an acid and this is not an acid. So what differentiates them? I told you that they have to contain hydrogen atom. Forget about sourness. We cannot taste methane, so it is not convenient to use the first criteria. Okay, so we cannot use taste all the time, but we have to fulfill the second criteria. Have to contain hydrogen atom. Here also have hydrogen atom, here also it have hydrogen atom. But why this is not an acid whereas this is an acid? Okay, so now if you see, they both contain hydrogen atom, which fulfills the second criteria. But what makes them different? What makes them different? The answer is in order to be an acid, the compound must have at least one replaceable hydrogen atom or ion. Remember the word, have to contain replaceable. Replaceable. That means the hydrogen atom which is present in a compound should be in a position so that it can leave the compound. That is not the case with methane. This hydrogen, any of the hydrogen cannot leave methane. But in this case, I will rub this methane since it is not an acid. And methane, in the formula of methane we have 4 hydrogen atoms, but neither of the hydrogen atoms can leave the compound, so this is not an acid. Now let me modify the second criteria. Have to contain, here I will write replaceable hydrogen atom or ion. Now if you see here, we have CH3, we have CH3, C, 3 hydrogen, then COO and H. This is the formula. Now which hydrogen atom in this particular compound is replaceable? Replaceable means the hydrogen atom or ion should be in a position to leave the compound, to leave the structure of the compound. Now if you mix water H2 with this compound, then this particular hydrogen which is present with this oxygen, it can literally leave the compound. It can just simply leave hydrogen, that means it can just simply leave the entire structure and it can be free. It will leave. That means as soon as you mix it with water, the CH3COO will become, COOH will become CH3COO minus, and this H which was initially hydrogen atom will be now converted into hydrogen plus, hydrogen ion, and this will combine with H2O. This will combine with H2O and it will give you H3O positive. H3O positive. Always remember that this hydrogen plus ion cannot exist alone on its own. This is not stable at all. H plus is just a single proton. It is not stable. Okay, so as soon as it becomes free, it will find one water molecule and it will combine with water molecule. It will combine with water molecule to give you H3O plus. This is called hydronium ion. Okay, so proton always exists as hydronium ion. Always remember. So what happens here? The thing that happened here is this hydrogen is a replaceable hydrogen. Not all hydrogen. See, this hydrogen, and this hydrogen, they are not replaceable. The only replaceable hydrogen is this one, which is present with this oxygen. Okay, so this hydrogen, it leaves behind this entire structure and it moves out as H plus, and this H plus combines with H2O which is present in the water to form H3O positive. Okay, so always remember that H plus always exists as H3O. That means acid cannot act when there is no water. If there is no water, then there is no acidity. If there is no water, there is no acidity. So to prove that, we have one experiment in our book. I will come to it later on. But first thing you have to remember is, when there is no water, there is no acidity. Okay. So why there is no acidity when there is no water? Because acidity is due to the replaceable hydrogen atom or ion. That means we can just simplify that acidity or acidic nature is because of the presence of H plus ion, and this H plus ion cannot exist on its own. It needs something on which it can with which it can combine, it can exist. So the thing with which it will combine and exist is H2O, that is water molecule. So if there is no water molecule, it has nothing to combine with and it will not show any acidity since it is not stable at all. So if we do not have any water in the surface or in the the reaction, then there will be no acidity at all. But when we have water or water molecule or any moisture in the surface or in the reaction, then this H plus will readily combine with this H2O and this will give you H3O plus, and which gives the acidity, which gives you the acidic nature. So this is the first and this is the second criteria. This is the most important criteria, to have to contain replaceable hydrogen atom or ion. I think till this you have clear. Now I will give you the definition of acid. You just need to write down the definition, make your notes yourself, don't rely on others. I will not give you any sort of notes since I'm doing the online class. So just follow whatever I am writing on the blackboard. Similarly, I will simultaneously I will give you some sort of small lines, small notes You just prepare them accordingly, you just write them accordingly and prepare your notes yourself. So here I have written a definition of acid, which is acid may be defined as a substance which releases one or more H plus ions in aqueous solution. Remember, in aqueous solution, these H plus ions exist as hydronium ion inside the bracket H3O positive. Do not forget to write this line, write this word, that is in aqueous solution. Aqueous solution means, if you recall from the previous chapter, the chapter number 1, there I told you what is the meaning of aqueous solution or aqueous medium. Aqueous medium or aqueous solution is the solution when you make a solution. That means you make a solution in presence of water. Okay, you take the solute and the solvent must be water, and when mix the solute with the solvent, you make the solution, and that solution is aqueous solution. So aqueous solution means something, the solution which you are making in presence of water, H2O. Water must be present. Then these H plus ions exist as hydronium ions inside the bracket H3O positive. Then I also have given two example. Example number 1 is HCl plus H2O gives H3O plus Cl minus, and here CH3COOH plus H2O gives you CH3COO minus plus H3O positive. So you write down this entire definition. You just pause it or take a screenshot of it and then you write down. Okay, since the definition of acid is done, now let's move on to the type of acids. Okay, when we talk about the type of acids, actually they are classified based on two major things. First one is their source and second one is their strength. So depending on these two criteria, we have two different type of classification. So first of all, let's move on to the first classification, that is based on their source. Based on their source. So based on their source, acids are broadly classified into two types. Number 1 is natural acid. Number 2 is mineral acid. Natural acid is also called organic acid, and then we have got the mineral acid. Two type of acids based on their sources. Based on their sources. Okay. Natural acids are those which contain naturally, that means which are formed naturally, and some natural substances contain natural acids. So for example, some food items, milk, that means the curd. Okay, the milk or the curd contains lactic acid. Then tomato, it contains oxalic acid. Then lemon, it contains citric acid. Then we have the tamarind. It contains tartaric acid. So these are example of some natural acid or organic acid. That means organic acids are those which are present in food substances or any other natural substances. So these are the examples. And then the second type we have with us is the mineral acid. Second type we have with us is the mineral acid. Okay, so mineral acids are those which are obtained from rocks or minerals, sometimes from the mouth of the volcanoes, and then sometimes those mineral acids are produced, they are manufactured in laboratories, in large industries, because these mineral acids are required for some industrial purposes, like hydrochloric acid, sulfuric acid. These are used in the pulp making process, in the paper mills and all, in textiles and different other uses, a lot of other uses. So some mineral acids are hydrochloric acid, hydrochloric acid, HCl. Then we have got sulfuric acid, then we have got nitric acid. So these are some example of mineral acids. Now let's talk about bases. What are bases? Base. So first, taste wise, how does base taste? So acid, they taste sour, and base, they taste bitter. Then base feel soapy. Base feel soapy. So these are the two important characteristics of base. And when we are asked to give definition of base, then these two criteria will not work. So when we give the definition of base, we have to give some appropriate scientific definition. So just like acid, acids are those which contain H plus, bases are those which contain OH minus. Okay, this is H plus, or we can also call it H3O plus, hydronium ion. So acids contain H plus proton or hydronium ion, whereas bases contain OH minus or hydroxide ions. Hydroxide ions. So on one hand we have acid which contain H plus or H3O plus, and bases which contain OH minus or hydroxide ion. Let's write the definition of base. Okay, so bases are the substance which are capable of releasing one or more OH minus ion in aqueous medium. This is the definition. Bases are the substances which are capable of releasing one or more OH minus ion in aqueous medium. This is the definition of base. So the main differences here: acids contain H plus, bases contain OH minus. The first difference in terms of more scientific aspect. Okay, and the similarity is both acidic and basic nature is counted, is calculated, is observed when the medium is aqueous. Okay, now let us write some example of bases like NaOH, sodium hydroxide. Along with the formula you also write the name, because you need to remember the compound by its name and the formula as well, because in the coming days, in the coming chapters, you are going to need them. You are going to use them. So you just write the name along with the formula and also remember them. Sodium hydroxide, we have got potassium hydroxide, CaOH2, calcium hydroxide, MgOH2, like this. Sodium hydroxide, potassium hydroxide, and you write down the name of these two bases on yourself. This will be calcium hydroxide, this will be magnesium hydroxide. Okay, this is also called milk of magnesia. This is called slack lime. Okay, so this is the common name. All right. Now, next question is how to identify whether a substance is acid or base. We know that acids are those which contain H plus, bases are those which contain OH minus. We also know that acids are those which taste sour, bases are those which taste soapy, which taste bitter. They do not taste soapy, sorry, they taste bitter and they feel soapy. I am talking about base. Now the question is, how can we identify? Okay, say for example I have two beakers of aqueous solution. One is acid, one is base. Which one is acid, which one is base? Neither I know nor you. How can you identify? It is not always safe to put dip your finger and taste it, because the acid may be strong acid. It may corrode your it may cause burn to your finger. Okay, so if you dip your finger and if you taste it, it may burn your tongue, it may burn your finger. Okay, so which one is acid, which one is base? In order to identify that, we use some substances which are called indicators. So indicators are those substances which helps us to determine whether a substance is acidic or basic. So when we talk about indicators, the first thing that comes to our mind, or the first thing that immediately we think of, is litmus paper. L-I-T-M-U-S, litmus paper. I believe all of you have seen litmus paper. They come in some strips, which is which is pink in color or red in color. They comes in strips. In a particular strip there are 10 or 20 kind of papers. So they are pink in color or red in color. Okay, so when you take one strip of a litmus paper and dip it inside an acid or base, you will see some immediate color changes. Okay, you will see some immediate color changes. So there are basically two type of litmus paper. One is called blue litmus paper, one is called red litmus paper. Now say for example you have picked one blue litmus paper. You have one blue litmus paper in your hand, and if you dip it in this solution, and if the color changes from blue to red, then it will be an acid, because acid changes blue litmus paper into red. Okay, so this means this particular beaker contains an acid. Now if you take the same litmus paper, that means if you you throw that paper away, now next time you take one fresh litmus paper, which is again a blue litmus paper, blue one. First you took the blue one, and the second time also you are taking the blue one itself, but you need to throw that blue litmus paper away the first time that we have used. Now again you have one blue litmus paper in your hand. Now you dip it in this solution. Now there will be no color changes, because this is base, and base cannot change blue litmus paper into red. Okay, blue litmus paper can be changed into red only and only by acid. When you dip in the base, the blue litmus paper, which is blue in color, will remain blue only. There will be no change. Now about the second type, we also have red litmus paper with us. So when we take red litmus paper and dip it inside base, then the red color will be changed into blue. And if you do the same activity with this other one, then there will be no change, because red cannot be changed into blue by acid. Red can be changed into blue only by base. Acid cannot change its color. Acids cannot change in color, so the color will remain same. So we have one indicator, litmus paper. Then we have some natural indicators as well. So for example, turmeric. Turmeric is an example of natural indicator. So sometimes while having our lunch, dinner, etc., we sometimes drop a bit of curry in our shirt, and the stain becomes yellow in color. The next day when you give this for washing, then this yellow color becomes red. Why? Because the soap that we mostly use in our homes, the soap is nothing but base only. Okay, soap is what? Soap is base only. So that base acts on this turmeric and change the color from yellow to red. Okay, so turmeric is also one indicator. Apart from these two indicators, we also use one more, that is methyl orange, which is called methyl orange, is an also indicator. And then we have got phenolphthalein. So litmus paper, turmeric, methyl orange and phenolphthalein, these are all indicators, different kind of indicators. So what are indicators? Indicators are those substances which helps us to determine whether a substance is an acid or base. Okay, so for this particular class, I think this is enough. Since this is only an introductory class, I do not want to make it lengthier. So this much is enough. You just take the basic knowledge of what is acid, what is base, what is the basic difference between an acid and a base, and how they are classified, what are their types, whether an acid is mineral acid or organic acid, and then what are the indicators, what are their uses. This much is enough. So in the next class, we will discuss in details about the properties of acids, how they react with different substances, and subsequently we will move on to base. So this much is enough. You just watch the video carefully, write down the notes yourself, and in case of doubt you can contact me. You can just WhatsApp me in my number. Thank you.